The spectral lines on my monitor are unmistakable, yet they defy the clean, predictable patterns we usually associate with cometary outgassing. It is currently 4 local time here at the observatory, and I have been staring at the data stream from the Meerkat radio telescope array in the Karoo Desert of South Africa for the last 6 hours without blinking. Or at least, it feels that way. The signal we are looking at, a distinct, sharp radio emission at 1,665 and 1,667 MHz, is technically the fingerprint of hydroxyl radicals, the fragmentation product of water molecules breaking down under sunlight. In any standard textbook, this would be the smoking gun that closes the case. Water means ice means comet, and comet means natural. But 3I Atlas is not a standard textbook case, and the sheer strength and modulation of this signal, arriving from an object that has otherwise behaved with such maddening inconsistency, makes this moment feel less like a conclusion and more like the opening sentence of a message we are barely beginning to read. To understand why my pulse is racing over a couple of emission lines on a spectroscopy plot, you have to understand the journey that brought us to this cold November morning in 2025. We have been tracking this visitor, designated 3I Atlas, since July 1st of this year. It is the third confirmed interstellar object to pass through our solar system, following the baffling Oumuamua in 2017 and the unmistakably cometary 2I Borisov in 2019. When the Atlas Survey Telescope in Chile first flagged it, the trajectory was the immediate giveaway. It wasn't orbiting our sunday. Its hyperbolic excess velocity was far too high. It was punching through the plane of our solar system at a speed and angle that screamed, outsider. It came from the direction of Sagittarius, dropping into our gravity well like a stone dropped from a bridge, and for the last 5 months, it has been the single most scrutinized object in the sky. But 3I Atlas has been fighting categorization every step of the way. When Oumuamua passed, we saw no tail, yet it accelerated as if pushed by gas. When Borisov passed, it looked exactly like a dirty snowball from our own Oort cloud. 3I Atlas seems to be trying to be both, or perhaps neither. We have confirmed images from the Hubble Space Telescope and the James Webb Space Telescope that show a coma, a fuzzy atmosphere, suggesting it is shedding material. That fits the comet label. But the radio signal we just captured changes the texture of that conversation. This is the first time we have ever detected a radio frequency transmission, albeit a natural one, from an interstellar object. We listened for Oumuamua with the Green Bank telescope and heard silence. We listened to Borisov and heard static. But 3I Atlas is speaking to us in the language of hydroxyl, and the volume is unexpectedly high for an object that, visually, appeared to be fainting just weeks ago. The signal arrived just as the object is emerging from its perihelion passage. On October 29th, it swung closest to the Sun, dipping just outside the orbit of Mars. We lost direct visual contact for a brief window as it passed behind the solar glare. A period of agonizing blindness where we could only simulate its position. We knew the heat of the Sun would roast its surface, potentially triggering massive outgassing events or, in a more dramatic scenario, causing the object to fragment entirely. There was a genuine fear that 3I Atlas would disintegrate, becoming nothing more than a cloud of interstellar dust before we could get a good look at it. Instead, it survived. And not only did it survive, it switched on. The data on my screen comes from the Meerkat Array's L-band receivers. We pointed the dishes at the coordinates RA, 14 hours 22 meters, dec negative 12 degrees 30, expecting to perhaps see a faint continuum of thermal noise. Instead, we got these twin peaks at 18 centimeters wavelength. Now, I need to be extremely precise here, because as a scientist, I am trained to be the skepticism in the room. These are absorption and emission lines consistent with the quantum transitions of the hydroxyl molecule. When water ice sublimates from a cometary nucleus, ultraviolet radiation from the Sun photodissociates the H2O into H and OH. The OH radical then fluoresces or absorbs background radio waves. This is a known physical process. However, the context of this emission is what keeps me awake. The signal indicates a production rate of water that does not match the visual magnitude of the comet. To put it simply, if it is dumping this much water to create this strong a radio signal, it should be brighter in the visible spectrum. It's radio loud, but optically dim, a discrepancy that implies the dust-to-gas ratio of this object is unlike anything we have seen in our local comets. It suggests a surface composition that is incredibly volatile rich, but strangely lacking in the silicate dust that makes comets shine by reflecting sunlight. This leads me back to the chemical anomalies we spotted with the James Webb Space Telescope back in August. We saw carbon dioxide, huge amounts of it. The CO2 to water ratio was off the charts compared to solar system comets, and now, this sudden surge in hydroxyl radio emission suggests that deep pockets of water ice have just been exposed, perhaps by a fracture in the crust caused by the thermal stress of perihelion. It is as if the object is shedding a skin. The unusual nature of the signal isn't just its existence, it's the timing. It didn't ramp up smoothly as it approached the Sunday. It spiked after perihelion. That is a behavior characteristic of a specific type of outburst, or perhaps a directed release. I have to address the elephant in the room, the hypothesis that my colleagues in the SETI community and the more theoretical branches of astrophysics have been whispering and sometimes shouting about. Is it artificial? The radio signal is narrowband, which is a hallmark of technology, but the frequency is exactly at the hydroxyl transition. If I were an alien civilization sending a probe, would I communicate at 1,667 MHz, a frequency naturally cluttered by cometary noise? Probably not, unless I wanted to camouflage my transmission as a natural event. But that is pure speculation, an ideal in data. The data says hydroxyl, but the behavior of the object that is emitting this hydroxyl is what gives the artificial theorists ammunition. Let's look at the trajectory analysis that just finished compiling on the secondary server. 3I Atlas is exhibiting non-gravitational acceleration. This is a dry term for a wild phenomenon. It means the object is moving differently than gravity alone would dictate. We saw this with Oumuamua, and we explained it away as outgassing jets of gas, acting like rocket thrusters pushing the object off course. But for Oumuamua, we didn't see the gas. For 3I Atlas, we see the gas we have, the hydroxyl signal right here, but the acceleration vector is strange. It's not strictly radial, pointing directly away from the sun as you would expect from solar heating. There is a tangential component. It's shifting sideways. If this were a simple comet, the jets would have to be firing in a very specific, sustained, and asymmetrical way to produce this path. It requires a rotation pole that is stable and an active region that stays in the sun. But the light curve data from the ground-based telescopes in Chile suggests the object is tumbling. A tumbling object should average out its thrust, leading to zero net non-gravitational acceleration. So, how does a tumbling rock steer itself? This is why the radio signal is so critical. It allows us to map the velocity of the gas. By using the Doppler shift of these very 1,665 MHz lines, we can measure how fast the gas is moving relative to the nucleus. We are seeing gas expansion velocities of nearly 600 meters per second. That is fast. It implies a very energetic release mechanism. If this were a standard sublimation process, the gas usually drifts away closer to the thermal speed. This gas is being ejected. Could it be pressurized pockets of exotic ices, carbon monoxide, nitrogen, or is the surface of 3I Atlas not a surface at all, but a rigid shell containing high-pressure volatiles? I am currently looking at the interference patterns from the MeerKAT data, checking for any underlying structure in the noise. There is a rhythmic pulsing in the intensity of the OH line, a period of roughly 16 hours. This matches the rotation period we derived from the optical light curves. This is good. It anchors the signal to the physical body. It confirms the signal is coming from the rotating nucleus. But the jets we are inferring from this radio data are collimated. They are tight beams of gas. In the images taken by amateur astronomers and verified by our team, we see these linear features extending for thousands of kilometers. Natural jets fan out. They disperse into a cone. These look like streaks, straight lines, and the radio map confirms a high density of hydroxyl along these narrow vectors. This collimation is extremely difficult to model with standard hydrodynamics. It requires a nozzle. Nature can create nozzle-like structures, vents, craters, fissures, but to maintain such tight collimation over such distances suggests a structural integrity to the vent that is hard to reconcile with a crumbling ball of ice. We must also consider the origin point. We trace the orbit back 10 million years, and it doesn't seem to originate from any of the nearby star systems we know. It has been drifting in the interstellar void for likely hundreds of millions, perhaps billions of years. The cosmic ray exposure alone should have polymerized its outer crust into a dark, organic tar, a crust that shields the ice inside. This fits with the fact that it was very faint until it got close to Mars. It needed the intense solar heat to crack that crust. The radio signal we are seeing now is the sound of that ancient ice finally screaming as it hits the vacuum. It is a sample of water from a star system that might have died before Earth was born. That is the romance of the science, the realization that these spectral lines are ghosts. But let's get back to the operational reality. The signal is strong enough that we are now triggering a target of opportunity 2.0 observation with the Green Bank telescope and the Deep Space Network. We want to listen at other frequencies. If this is truly just hydroxyl, we should see corresponding transitions in the UV and IR. We have alerts out to the Swift Observatory to look for the UV counterparts. But if, and this is a massive if, there is any underlying carrier wave, any structure that isn't quantum mechanical nature, the larger radio dishes will find it. The meerkat detection is the dinner bell. Now everyone is going to come to the table. I am particularly interested in the polarization data. The search results from our preliminary scan show the radio waves are unpolarized, which is typical for thermal or fluorescent emission. However, the optical light reflected from the dust coma showed extreme negative polarization back in July. That was one of the early red flags. Polarization tells you about the scattering surface, the grain size, the porosity. Extreme negative polarization is rare. It suggests the dust grains are fluffy, porous aggregates, almost like fractals. Or, it suggests the light is scattering off surfaces that are geometrically regular. When you combine geometrically regular scatterers with collimated jets and non-gravitational acceleration, you start to see why the alien probe email thread in my inbox is currently revenants, 500 messages long. I don't subscribe to it, but I can't dismiss the anomalies. My job is to prove it's a rock. And right now, the rock is making it very hard. The proximity to Earth is the next phase. 3I Atlas is moving away from the Sun but towards us. It will make its closest approach to Earth on December 19th. It won't hit us, it will be 270 million kilometers away, safe and sound. But that is close enough for us to resolve the nucleus if we use the planetary radar at Goldstone. We are preparing to ping it. If we can bounce a radar signal off it, we can get a shape model. Is it a cigar? A pancake? A sphere? The radio signal we are receiving now helps us calibrate those radar attempts because we know exactly where the gas is densest, which might attenuate the radar return. I am zooming in on the frequency drift. The Doppler shift is changing as the object rotates and moves. It's a beautiful curve, a perfect sine wave of physics. It proves the emitter is on the surface. But look at this glitch, a sudden jump in frequency. A glitch in the rotation? Did the object just spin up? Comets do this. When they vent gas, the torque spins them up like a top. If 3I Atlas is spinning up, it might tear itself apart before December. This radio signal might be the death rattle. The intensity of the hydroxyl line increased by 20% in the last hour. That is a massive flare. Something just broke on the surface. A cliff collapsed? A pocket exploded? The implications of this water detection are profound even without the aliens. It confirms that the chemistry of water formation is universal. The water in this interstellar visitor is made of hydrogen and oxygen, just like the water in my coffee cup. The physics is the same. The universe is consistent. But the ratios of isotopes, that is what we will look for next. Is the water heavy? Does it have more deuterium than Earth water? If so, it tells us this object formed in a very cold environment, far from its parent star. If it has light water, it formed closer in. This radio signal, if we can integrate it long enough, might give us the deuterium to hydrogen ratio. That is the fingerprint of its birth. We are doing archaeology on a timeline of billions of years using a radio antenna in the desert. I am watching the feed from the European Space Agency's Trace Gas Orbiter, TGO, at Mars. They observed 3I Atlas when it flew by Mars earlier in October. They saw the fuzzy white dot. But now we are correlating their atmospheric data with our radio data. They picked up a spike in protons hydrogen. We are picking up the OH. H plus OH equals H2O. The math works. It is definitely water. The unusual signal is not a transmission of prime numbers, it is a transmission of elemental truth. It is a validation that we are not special in our composition. However, I cannot shake the feeling of the visual anomalies. The straightness of the tails seen in the amateur images from November 16th and 17th. I have the JPEGs open on my second monitor. They look like laser beams. Standard cometary tails are swept back by the solar wind. They curve. These features are rigid. Is it possible we are seeing a dust tube, a shadow effect? Or is the velocity of the ejected particles so high, remember that 600 meters s figure from the radio width, that they are punching through the solar wind unaffected? If they are moving that fast, the pressure inside the nucleus must be immense. Let's talk about the dark periods. There were days in September when the object went quiet. No coma, no activity. Then it flared, then quiet. Now this radio blast. This intermittency is puzzling. Comets usually warm up and stay active until they cool down. Pulsed activity implies a trigger. Is it rotation bringing a specific active spot into the sun? Or is it internal instability? The artificial argument would be that it's a controlled burn. The natural argument is that it's a landslide. As a scientist, I bet on the landslide, but I keep collecting data to ensure I'm not betting against the house. The signal is stable now. The intensity has plateaued. We are recording terabytes of baseband data. Every wiggle of the waveform is being saved. In the coming weeks, we will feed this into supercomputers to look for anything hidden in the noise. We will stack the frames. We will cross-correlate with the optical jitter. We will throw every algorithm we have at it. For the public, the headline will be, Interstellar Comet Has Water. For us, the headline is, Interstellar Object 3I Atlas, confirmed as volatile rich hyperbolic body with high-velocity collimated ejecta and anomalous non-gravitational acceleration. It's a mouthful, but it's the truth. The radio signal is the key that unlocked the chemical composition. It proved the gas is there. It proved the rocket has fuel. Now we just need to understand the engine. I'm looking at the timestamp. It's been 7 hours since the detection began. The object is receding. The signal strength will drop as the inverse square of the distance. We have a limited window. Maybe another month of good radio data before it gets too quiet. This is the golden hour. We are the first humans to listen to the breath of a rock from another star. It sounds like static hiss to the ear, but on the spectrum analyzer, it looks like a mountain. A double-peaked mountain of hydroxyl. There is a philosophical weight to this. We sit here on Earth, scanning the heavens, desperate for a connection. We find a rock. We listen to the rock. The rock says, water. It's almost poetic. The essential ingredient of life is what announces the visitor. It doesn't send poetry or math. It sends the signature of the medium in which life swims. Maybe that is the message. Or maybe I'm just tired and over-romanticizing a sublimation event. I need to log the calibration settings for the next shift. The gain on the L-band receivers needs to be adjusted. The background noise from the galactic plane is rising as the target moves into a denser star field. We need to subtract that out. This is the grunt work of discovery. It's not dramatic flashes. It's signal-to-noise ratios and bandpass filters. But every time I refresh the plot and see those lines still there, standing tall against the cosmic static, I get a shiver. It's real. It's here. And it's talking. The coordination with the optical teams is crucial. I'm typing a message to the team at the VLT, Very Large Telescope, in Chile. I need them to get a spectrum of the nucleus right now, while the radio signal is peaking. If we can match an optical flare to this radio flare, we can pinpoint the active region. We can map the surface of an object we will never visit. That is the power of multi-messenger astronomy. Radio ears and optical eyes working together. I am also keeping an eye on the orbital determination updates. The non-gravitational parameter, A1, is being refined. With this new mass loss data, inferred from the radio signal strength, we can calculate the mass of the object more widely. If the mass is low and the force is high, it's a thin object. If the mass is high and the force is high, the jets are incredibly powerful. The current numbers suggest a density lower than water ice. It's porous. Like aerogel. Or a hollow structure? No. Stick to the aerogel. Fractal aggregate of icy dust. That's the term. It sounds less sci-fi. The Meerkat array is performing beautifully. 64 dishes moving in unison. A mechanical ear turned to the void. The precision required to track 3I Atlas, moving at 58 kilometers per second relative to the sun, is immense. We are tracking a bullet with a microscope. As the sun begins to rise here, washing out the optical observations, the radio eyes remain open. Radio doesn't care about the blue sky. We can listen all day, and we will. We will listen until 3I Atlas fades back into the dark, heading for the edge of the system, past Jupiter, past Pluto, and back into the interstellar deep. It won't return. This is a one-time encounter, a brief handshake with eternity. And it started with this beep. This unusual radio signal. Unusual because it shouldn't be this loud. Unusual because it shouldn't be this fast. Unusual because it is the first time the galaxy has rung our doorbell and we were awake to hear it ring. I am saving the dataset now. File name, 3i, Atlas, Meerkat, Leband, OH, detection, 20251128. A boring name for a historic file. I'll add a note in the metadata. First detection of interstellar hydroxyl emission. Strong signal. Anomalous velocity structure. That covers it. I lean back in my chair. The screens are still flickering with data. The coffee is cold. The universe is vast. And for the first time, I feel like we have a finger on its pulse. 3i Atlas is not just a rock. It's a laboratory. It's a traveler. And for a brief moment, it's ours. The signal persists. The hum of the cooling fans in the server room is the only sound in the control room. I close my eyes and listen. Not to the fans, but to the graph. 1,667 megahertzes. The hum of the universe, the mystery of the straight jets, seen in the amateur images, remains the most bothersome detail. I'm pulling up the paper by Avi Loeb again. He argues that if the jets are truly collimated, they imply a nozzle functionality. A natural nozzle is possible, a deep pit with vertical walls. But on a rotating, tumbling body, how does the jet stay straight? The lighthouse effect should curve it into a spiral. The fact that it looks linear implies that the ejection is occurring on a timescale much shorter than the rotation. A burst, or the rotation axis, is aligned with the jet, which contradicts the light curve. Or, the particles are moving so fast that the rotation is negligible during the travel time. If the particles are moving at relativistic speeds. No, that's crazy. But even at 10 km/s, they would form a straighter line. Our radio data says 0.6 km/s. There is a discrepancy between the radio gas speed and the optical jet morphology. This is where the work begins. This is where we earn our grants. We have to reconcile the slow gas with the fast-looking jets. Maybe there are two components: a slow thermal outgassing, the OH we hear, and a fast-driven particle beam, the jets we see. A dual-mode emission. I am now looking at the orbital ephemeris for December 19th. The Christmas gift, as the press calls it. We will have the best viewing geometry then. We will be looking at the object from the side, illuminated by the Sunday. The phase angle will be perfect for checking the scattering properties. If there is any strange surface feature, a shiny patch, a metal plate, kidding, a large crater, we might see the glint. The radio signal we detected today gives us the when to look. It tells us the object is active now. We don't have to wait. We need to observe continuously. The feeling of being on the frontier is palpable. Most days, astronomy is about statistics, counting stars, classifying galaxies. But this is hunting. We are tracking a specific individual entity that is fleeing the scene. It has a personality. It has behavior. It ignores gravity. It spits water. It hums in the radio spectrum. It is the most interesting thing in the sky. I'm preparing the telegram for the astronomers' telegram service. Meerkat detection of OH maser-like emission from 3i Atlas. Maser-like? Is it stimulated emission? The intensity is high. Maybe it is natural lasing? That happens in star-forming regions. If 3i Atlas is a natural maser, that would explain the brightness. It would mean the gas conditions are perfect for amplification. A natural radio amplifier flying through the solar system. That is a cool thought. A cosmic boombox. The sun is fully up now. The optical astronomers are packing up. I'm just getting started. The radio sky is always open. 3i Atlas is out there, singing its song of water and ice. And I'm going to record every single note.